All right. I can see a lot of you joining, so I think it's safe to get started. Again, hello everyone and good morning, and thank you for joining the Info Day webinar today. This webinar will be focusing on the first open call of the EU-funded 5G IANA project. And today we will be taking you through everything you need to know about the project as a whole, but also, of course, the open call and the open call procedures. My name is Sevi Christoforou, and I am a Communications and Dissemination Officer with ICCS, the Institute of Communication and Computer Systems in Athens, Greece. And I'm also the Dissemination Task Leader for 5G IANA. Before we get started, I would like to inform you that throughout the session, throughout the presentations, you will have the opportunity to submit your questions on the chat box that you can find on your control panel. However, we will be taking all questions at one time towards the end, where we have saved a few minutes for a Q&A session. And of course, then you will have the opportunity to also use your microphone to ask any questions to the speakers directly. Now, for introducing the agenda of today, I would like to ask the speakers to turn on their webcam so we can see you. All right. Our first speaker for today is Irini Liotou. She is a senior researcher and project manager at the IANA group of ICCS and the project coordinator of 5G IANA. Today, she will be taking us through the 5G IANA project and how the project can benefit the work of SMEs and startups in the automotive sector. Hello, Irini. Next, and for describing the 5G IANA platform offerings, we have Dimitris Klonidis and Konstantinos Katsaros. They are both heavily involved in the technical management of the 5G IANA project. And Dimitris is the head of the network softwareization and IoT unit with Ubitech, while Konstantinos is a senior researcher leading also the Intelligent Networks and Services Department, IANA's group of ICCS. Then we have with us today Matteo Andolfi. He's an R&D senior software engineer at Nextworks, and he's also a network application expert who will be presenting the 5G IANA NAPs and looking into ways of building 5G-enabled services for the automotive sector. And before we move on to the Q&A session towards the end, I will be taking you through all the practical issues, the practicalities of the 5G IANA open call, looking at all the available material that can be helpful throughout the procedure, but also the application process. I wouldn't want to take any more of the time, so Irini.
Hello, good morning everyone. Let me share my screen. Okay, so welcome everyone to our Info Day. Thank you, Seb, for the introduction. So I am Irini Liotou. I am Project Coordinator Deputy of 5G IANA. The goal of the set of presentations that we have prepared for you today is to explain to you the basics of our project. So what's it in for the SME, so what's it in for you. Please note that this is a starting point, so we want to explain to you the benefits that we have, our platform has for the SMEs, but our goal is not to explain to you all the technical details. There will inevitably be technical details, but really do not be overwhelmed or scared because you don't need really to understand everything. So our goal is to trigger your initial interest and then to attract you and ask you to apply to our open call. More details then will follow on a one-to-one basis as long as you are interested and you apply to the open call, and we will build a longer-term relationship between us. So a few things about 5G IANA. So 5G IANA is an H2020 ICT41 project. It started in June 2021 and it will be concluded in November 2024. So this means we have still some years ahead of us. Our consortium consists of 16 partners from 8 EU countries. The majority of the partners actually is SMEs, which means that we are in your shoes, so we understand your needs, but we also understand your capacities and your interests. And we use the SMEs in order to really reflect on you. So how it all started, initially there was this ICT 41 call scope from the EU that had the objective to fund some projects that would be in the position to provide enhanced experimentation infrastructure so that third-party experimenters would be able to test their applications. By third-party experimenters, we actually, at least in our project, mean you, so SMEs and startups. Also, the scope of this call was to provide integrated, open, and fully featured network platforms that are tailored to specific vertical sectors. And in our case, this is the automotive vertical sector. Also to design and create 5G open source repositories for a wider and broader use. So taking this call scope, IANA has tailored its objectives and made them really relevant to the SMEs and startups. Our goal, first of all, is to provide an automotive open experimental platform. We call it AOP. It's not very fancy, we know, that will actually be at the disposal of a third party, so you. Also to implement an open repository environment for network application and virtual network functions. Both of these terms are going to be explained to you later, but for now you can imagine that virtual network functions are just pieces of software, and if you chain everything together, you create a NetApp towards a specific service. Also, the goal of the project relative to SMEs is to implement some relevant use cases. So we have 7 use cases in our project with the goal to validate actually and assess the platform that we have prepared and we are still developing. And finally, to create some new business opportunities for the startups and the SMEs in the automotive sector. So overall, we invite you to leverage our platform. We are addressed, so the audience of our platform is actually any legal entity in the form of SME or startup that is working in the concept of network applications in the automotive vertical, or even that is interested in working in this concept. So any SME that is willing to develop a product, a service, a functionality, an algorithm that leverages the 5G capabilities that our 5G platform offers. So the goal of the set of presentations today will be to explain to you how you can benefit from leveraging our platform, what we offer to you, but also what we expect from you as input in this process and as output, of course, and how you can practically get involved through our open call. So you are an SME and you are now wondering whether you fit this open call. Here we have an indicative list of profiles that your SME should have, but this list is not exhaustive by any means. So broadly speaking, you could be a service creator, so a software developer in the wider sense, or a service provider, which means that you are not really developing the software yourselves. You could be an application and network functions developer, either of those. So you develop what we call in our project application functions AF or network functions NF that can then be used chained together in order to create the network applications. Or you could be the network application developer directly or the network application provider. And of course, some of these roles even may overlap. So you could be creator and provider at the same time. So what would the gains be for you in case you really decide to be involved in this procedure? First of all, you will gain access to a canvas of technological solutions that will help you in order to develop new functions and services in the automotive landscape. You would be able to test and validate existing or new services or even update existing services in real time. So this means that you may have currently a service or an application that is working offline and you want to make it 5G ready. So this is your opportunity. Also, you will gain access to real-life 5G resources. So this means real hardware resources, real vehicles. We even have autonomous vehicles. We have onboard units, roadside units. We have, of course, edge and MEC servers. And we even have some digital twins of this hardware. You will get the mentorship and support from our experts, both network and automotive expertise is available in the consortium. And also, in case you are wondering how can 5G really make a difference into my business, we will also offer you some guidance to help you build your business model in this context. Of course, you will gain inevitably visibility towards the Commission and our broader network in the 5G and automotive community. So practically speaking, what we offer to you. Let's discuss about the tools first, and then we'll discuss about the actual support. First of all, we are offering you mechanisms to help you easily design distributed intelligence services. So we try to make everything intuitive in this procedure. These mechanisms span from the remote cloud. So you can imagine the remote cloud as the software and the resources available in our 5G testbed, up to the far edge segment. So you can imagine this as the end user perspective. So the OBUs, the vehicles, etc. And to request the provisioning of these mechanisms and services on top of the 5G enabled infrastructure. So practically speaking, the tools is the access to our 5G IANA platform, where you can develop, deploy, and test your automotive services. We offer you a catalog of available application functions, network functions, and network applications. These are, you can see the numbers a lot, so you can do combinations of your own software with these available ones and build even new services. We offer you the tools to prepare and onboard your own application functions, network functions, or NetApp on our platform. Also important is that we will offer you these indicative examples of our own use cases, so you will see an end-to-end real working example of how an automotive service is implemented on the 5G IANA platform. I have some examples later. And we offer you also remote accessibility to 5G resources through our testbeds, but also remote accessibility to the OBU and RSU resources and vehicles through our platform. Again, to emphasize that the vehicles are real, but we also will offer you a digital twin, which we find to be very useful, especially for some pre-testing preparation phase of the actual experimentation. In the next year of the project, we will offer AI/ML support also to your services. This will be actually in our second open call, but we can discuss things even from now. And in terms of support, you are not alone. As I mentioned, you don't have to understand everything. You will have the technical presentations will follow, and some of the details may seem too much. But don't be afraid. We are preparing a technical manual that describes everything about the platform. So how you can really build your network applications on the platform, even what will be the KPIs that will be displayed to you. You can imagine this as the user guide when you purchase a software or a product. Also, we will offer you a manual of the application functions, network functions, and NetApps that are already available by the platform. So here we will provide to you the description of them, as well as the input that they require to function and the output that they produce. In this way, you will be able to understand how you can potentially interact with our own functions. Of course, some parallel also material will be the webinars that we will organize, the technical deliverables, which we have ensured all of them will be public, and so on. Now it is also important to emphasize that following the open call, and some SMEs will be eventually be selected to participate in the actual experimentation. We split it into two phases. The first one is the pre-testing phase, which will start in June, this summer. During the pre-testing phase, we will try to better understand your needs. We will discuss on a one-to-one basis. We will do some tests if you already have software to understand whether it is already interoperable with our platform or not. And of course, we will train you through our platform, NetApps, and all the procedures. And then the actual experimentation and validation phase will start later in the summer up to October, where you will really have the time to do your actual experiments and get the KPIs that you need to better understand how they work. We will offer you business model mentoring to understand whether this makes an impact to your business portfolio. And last but really not least is that the best performing experimenter by this procedure will gain 15,000 euros. We already have drafted the criteria under which this experimenter will be selected, and it is all available in a document that Sevi, my colleague, will explain to you later where to find. Just a few examples before I close my presentation. So the automotive applications, so NetApp categories that our consortium will offer to you as practical examples have to do with vehicle movement, hazard notification, infotainment, smart traffic planning scenarios. And we even have one vertical agnostic case that has to do with network status monitoring and predictive quality of service. So the 7 use cases of our project are the following. I will not go into details for the sake of time. Everything is in our website. However, some have to do with remote driving and maneuvers coordination. Some have to do with virtual or AR content delivery. And some have to do with more PPDR-related aspects, such as high-risk driving detection or situational awareness. The 2 test beds that we offer are the following: one in the city of Ulm in Germany, operated by Nokia, and another one in Ljubljana, Slovenia, operated by Telekom Slovenia. You will get all the details later by my colleague Dimitris. And finally, I am discussing so long about the 5G IANA platform, but have not showed you how it looks like. So this is a very abstract, zoomed out view of the 5G IANA platform. Of course, it's much more complicated. You will see an overwhelming slide later. You don't need to understand the details. What you need to understand is how to interface with our platform. So you will have an entry point through the NetApp orchestration and development component, it's how we call it, and you will have an exit point to really monitor the KPIs and have the analytics. And you will have at the disposal everything you see at the bottom, so resources spanning from the central cloud up to the far edge. So this is also the exit point of my presentation and the entry point to Dimitris, our technical coordinator. Thank you very much, and you are welcome to ask your questions in the chat, and we will address them all later or by email if we don't have time.
Okay, thank you, Irini. So I will move on from here. Hope you hear me well. Right, so I will give a few more information about what 5G IANA offers, and in order to do so, I will start with an overview because we get about the 5G IANA platform, so basically what are on a high level, okay, the different parts of this platform, but then focusing more on the parts that have to do with you, with third parties, and what third parties are getting involved here, and of course the capabilities that are offered through it, trying to summarize also a bit what is the expected process for the end users completely from the technical point of view, okay, for the technical, let's say, interfacing with 5G IANA. The procedures will be explained, of course, later. So, what is this 5G IANA platform? The platform has 3 main functionalities. Basic one, of course, is the application of services that we are going to, that are developed. It offers all the capabilities in order to do the deployment of this. Essentially, we are talking about the registration and the onboarding of the specific components. Could be application functions, could be network functions that compose the whole application. And doesn't need to have the whole pack here, because then there is, as it was said by Irini, extensive repository where a lot of them can be reused from applications that already developed through the project. We're talking also about pre-testing over the DevOps environment here, and use of actual hardware elements, of course, to incorporate new ones. The second stage, okay, which is the further the evolution, which allows also for more advanced testing, is the runtime configuration of the applications, is the actual orchestration, as we say, any kind of changes to the application coming from the end user or from monitor parameters through the network according to certain policies can change the actual flow of an application, for example, scaling to more CPU cores, okay, or higher memory, because we need to accommodate, for example, more users and so on for certain application. These kind of functions are realized through the runtime configuration, and then of course the final one is the platform per se is used for the validation and demonstration of the application. This is a quite detailed view, I would say. There's much more detailed, of course, once we go to the technical development. It's the one that shows all the different elements. Of course, don't worry, I'm not going to go through each one of them. Just want here to say that in this upper left corner, there is the entry point for the application onboarding, so it has all the graphical in order to bring the different components, okay, the application components compose the graph. Linked to this is, of course, the repository for the automotive applications, the reusable automotive application with the service components. And then we go to a bit more technical part. All of this is connected through a two-layer orchestration process. The upper one has to do with the application orchestration, and this includes all the module this includes all the modules that relate with the direct orchestration of the application level, which interfaces, of course, with below here the slice management module responsible according to the request that it receives from the different applications to create the different slices, do the resource management, and even more importantly, the interfacing with the southbound infrastructure layer. So, in order to complete the whole infrastructure, of course, down here we have the experimentation infrastructure, an infrastructure that extends, its capability extends from the far edge to the edge to the core part. And the last section, okay, here is the part where we add all the monitoring, the analytics, and the intelligence. It's the part which is responsible in order to collect data from the infrastructure, collect the data also from the applications that are running, do the analysis, apply some intelligent mechanisms, okay, and of course at the end handle the runtime configuration required for the application orchestration, providing also details to the dashboard at the end. So if we want to focus more specifically, okay, to what the end user requires, we are talking about essentially those four components here, as far as the third party is concerned, as far as you are concerned. The first has to do, of course, with the whole mechanism of the network application onboarding and the use of the components, and then NetApp. Directly, I guess, to some examples here in order to see, because I try to summarize, in one slide all the different parts. There is a graphical user interface, like the one you see here on the left. The first thing in this corner up here, you see the four main, up here, there are the four main functions of this platform, starting from down here, the components. Okay, the components is essentially the functions. This is the part where we list all the available functions, application or network functions, and of course we can create a new one, giving a set of parameters. The next step is to go and compose an application graph, like an example you see here. So we have this, each one of these are different images that are linked in a certain way between them. we can configure, of course, certain parameters that have to do with these links, like delay, bandwidth, characteristics, and so on. And once this is composed, then essentially in this area, then essentially we have a NetApp that is created. And of course, all the different applications that already exist have a list of the network applications. Okay, so we're talking essentially about two lists, one that has to do with each individual component, and the second one that has to do with linked components forming network applications. Once this is ready, we proceed, of course, to the actual instantiation of the service or the deployment of the service in this case. And then in this part, there are the instances, and we can select also through a number of monitoring parameters in all of these different components. There is a mechanism also to have a dashboard where we see this kind of monitoring information. In total, as you see here, or individually for certain applications, a lot also of logging here about the deployment, the status, and so on. Okay, so there are many of these mechanisms through this graphical user interface. Attached to this, it's also the virtualized function repository that I mentioned before. So the repository is the one that hosts a quite extensive set of functions that the intention is, of course, to be reused or to create new ones or re-edited and create new ones. Currently, at the moment, there are 49 virtualized functions today. And I'm saying this 49 is basically fully functional. It's not the total number. The total number will reach, it's expected to reach close to 70, as Irini said before. But these are what we currently have and fully functional. There are many more under development. 39 of these are application functions. They are related to specific applications. And the most important, I think, for all of you is also the network functions. There are 10 specific network functions in order to provide the connections. Again, there is a lot of work in this lower part about the network functions, which are expected also to increase to over 20. Some examples are shown down here. This is a very indicative, okay, it's not an exhaustive list, just provided some examples of what could be an application function, or what could be a network function in this case. Going further down now to the infrastructure. Okay, so we're talking about interfacing with the actual virtualized infrastructure. Is basically whatever application we're going to create with, what is it going to interface? Okay, what we can each end user can play with. Okay, the virtualized environment, okay, is the part where, of course, the network applications are deployed, running. And these virtualized domains extend essentially from far edge, which is the part of the vehicle, okay, the OBU, or the part of the RSU, the roadside unit. Then in the middle, it's the edge, of course, and further throughout the continuum, okay, we can, of course, we consider, of course, the cloud. And as far as the far edge infrastructure concerns, essentially we're talking about OBUs and RSUs. The key offerings here are 5G connectivity, short-range communication, of course, to provide interoperability also with legacy devices. We have sensor data management, and I think it's a very nice addition is this also it's the OBU positioning service that we have. The very nice addition is the on-vehicle man, which is a lightweight, essentially orchestration tool for the OBU. Some remarks here when we have virtualized infrastructure. This is the part where we can do the selection of the hardware with proper characteristics, of course, for implementing OBU and RSU functionalities according to the resources, to the physical infrastructure, kernel version, a variety of interfaces, of course, for that. Selection of suitable container orchestrator, and this is the vehicle manual, like a lightweight orchestrator for use more specifically in the far edge domain, controlling any attached devices to the vehicle, and implementation also of specific and standardized communication protocols that have to do with the connection among the different functions. I have also a couple of examples of very interesting examples, I think, from partners. One is from Lynx. It's an onboard unit with these specific characteristics that has been developed at the moment, and of course it will be available for testing. And another very interesting one is also the Vega solution. It is this vehicle, okay, that is offered by Biologics. But what I would like to say, it's not just the vehicle. I think it's very interesting, okay, also the digital twin that is offered for this vehicle, okay, through a Carla simulator that is also available, and that allows, okay, also even if in a pre-testing phase, even if not using the actual car, to do some very nice simulations, okay, of different functionalities that are offered from this vehicle. Again, certain characteristics are shown here, and of course it's open for more questions. Finally, going to the experimentation infrastructure. Okay, all of these are nice, but at the end, where we are going to do the before that, of course, I would say that we offer the whole infrastructure in order to do the off-site testing in a DevOps level. Okay, so we can, before we do any kind of an actual deployment over the infrastructure, we follow a certain methodology for doing the onboarding of application to see that everything is properly connected and communicate to solve any issues, interoperability issues we have. This is quite important, okay, in order to go to this facility. Okay, this is the facility that essentially offered by Nokia. It's very extensive. I think in this sector of automotive, it's one of the most advanced in Europe. It has a certain connectivity. There are two sites. Essentially, we're going to use one of these, which is in Ulm, in Germany. Okay, we're talking here essentially first about the 5G core, forming the heart of the whole 5G network and providing all the capabilities for mobility management, routing. There are security features, policy control, etc. This architecture, of course, of the 5G core is built using cloud-native technology, including also 5G service-based architecture and a set of specific network functions that are already implemented, including, of course, AMF and UPF connectivity. Then we have the sites for the G-Node bits, which are responsible for the radio resource management. And at this end, okay, of the access end, there are 4 antenna sites that are connected with optical cables then to the G-Node B. And all of this, the G-Node B, of course, is located at the Nokia laboratory, and where the servers also exist for the. Okay, so this is a figure of the platform, okay, the whole platform that is the Nokia infrastructure. Okay, here on the right, it's essentially the Nokia testbed, and behind the connectivity, okay, to the different parts of G-Node bits and then the vehicles, we have a couple of servers where we do the deployment of the 5G IANA platform server, and of course remote connection with GitLab server for or other sites, okay, is also possible, is something that we foresee. There is a second server as well in order to emulate all the edge server type of functionalities, okay, or the make part of the services, okay, where, for example, we have Kubernetes workers, different Kubernetes workers being deployed for different applications that running over the test equipment, of course, at the testbed site. Now, I'm closing with this because from a technical point of view, okay, just one slide in order to see how we foresee, okay, all the process, the technical process. Once there is an application, there is great interest, of course, and for this, what are the different steps we see needs to be taken in order to proceed. The first one, the first step, quite critical, is the preparation. It's the part where we need to together the third parties and also us to check what are the existing application functions, the network functions, what can be reused, what are the requirements also from the side of the third parties in order to be connected, how specific hardware and software will be used, again, what are the requirements for this, and to design even commonly design potential network applications that are and the required components and interfacing. The second is the process where we actually do the network application composition and the onboarding of the different components, connection with the existing ones. Once this is done, we move essentially to a pre-testing phase, and this is the deployment. Okay, so we start with the deployment, with an instantiation over an infrastructure, with the pre-testing infrastructure that I mentioned before, and it's the part where we do kind of validation of the proper functionality. If there are things that needs to be improved, okay, or changed. And then, of course, the final step, okay, is the testing and the experimentation, is the part where we validate the network application over the infrastructure. We have the measurements, collection of data, and at the end, we should not forget that there is also a reporting of the whole process. I'm closing with this. Okay, thank you very much. Happy also to answer. I know there may be a lot of questions, but I hope I could give you an overall view, okay, an overview of what are the basic things to consider, okay, and what are the key offerings here for this plan. So thank you.
Thank you, Dimitris. All right, let's turn to our last presentation. Matteo?
Yeah, I will share my screen in just a moment. Okay. Okay, I hope you can see my screen. So in this presentation, we speak about the network application in IANA. What is a network application? How it can be used? And in which way you can create a network application from scratch? This is the agenda of my presentation. In the beginning, we talk about the definition used in the IANA, like network application, atomic component, application function, network function, and so on. After that, we talk about the NetApp modeling, how an SMEs can create a network application in a simple way, and what are the building blocks of a network application, and how a network application can be used in the automotive context. Finally, I will show some real example of network application. Let's start by defining what is an atomic component. As Dimitri said in our previous presentation, an atomic component is a virtualizable function that is deployed in a container. In a simple words, an atomic component is more or less a Docker image that runs on an executor to do something. There are two categories of atomic components: the application function, that which implements the logic of the application, and some example of application function can be a remote driving module which, for example, receive direction, angle, and speed from the actuator and moves the vehicle. Or can be another example of application function can be an hazardous driving behavior detection, which is responsible for detecting and evaluating the driving events. Let's say, for example, the harsh braking, the harsh acceleration, the speeding, the mobile use, and so on. After the application function, we can speak about the network function that implements the communication between the application function. And for example, a typical network function can be the sensor data capturing, which collects data related to distance and angle of a vehicle to near obstacle from sensor. As you can see in the picture, an atomic component is composed by an atomic component template, a license folder, a documentation folder, and a test case folder. The three folders, of course, are self-explanatory. The license folder contains the license of the atomic component, if the atomic component is open source or not. The documentation folder contains the documentation of the atomic component, so how it can be used, and how an SMEs can use the atomic component to build a network application. And the test case contains all the test cases that are used to validating and evaluating the atomic component. In this way, a third party is sure that the component that he uses is stable. After the atomic component is defined, we can move to the definition of network application, also called NAP in the 5G project. An app is a virtualized composite network application that can be deployed over a 5G infrastructure and can use 5G service. We can view a network application as a composition of atomic components that can communicate with each other and can be instantiated separately with different requirements. This definition of network application leads to a scalable vertical service deployment, which takes into consideration the availability of the processing resource in the edge and cloud service. And of course, taking into consideration also the network application developer requirements. An NetApp is defined with a NetApp package, as you can see in the picture, which is composed with several items. A set of application network function descriptor package that describe the atomic components used in this network application. A NetApp template, a description of a network application with a specific information model. A license folder, again, a documentation folder, and a test case folder. In this folder, again, are contained all the licenses of the atomic components, all the documentation of atomic components, and so on. As we already said, the NetApps is a composition of atomic components which communicate within each other using direct exposure interface. A NetApp also expose their interface, which are derived from the atomic component that compose it. From a high-level point of view, we can see a NetApp as a building block which can be linked with other NetApps. With this in mind, we can move to the vertical service definition. A vertical service is a combination of a network application in different network segments. As you can see in the picture, we have three different network segments: the central cloud, the edge, and the OBU. Let's say call it also the extreme edge. In each of these network segments, we have several application and network functions that are organized in the NetApps, network application. In this picture, we can see a use case that is in the 5G IANA project called Real-Time Road Network Risk Assessment. The categorization of NetApps does not follow some strict rules. For example, in this picture, we can identify several network applications. As you can see, we can identify, for example, one NetApp which include application function 1, 2, and 3, and network function 1, 2, and 3 from the outside, and one NetApp which include application function 4 and 5, and the other network function 1, 2, and 3 from the edge and cloud side. But we can identify also other network application. For example, we can identify one NetApp which include application function 1, 2, and 3 from the other side. That is the hazardous monitoring, the network communication network function, network application, sorry, and the cloud storing cloud side network application, the application function 4 and 5. Let's quickly see how a NetApp developer can develop his own network application. The NetApp developer is supported by using a GUI, showed also by Dimitris in the previous presentation, that helps to compose the network application. First, the NetApp developer needs to add the atomic components to be used, of course. A third party can use the already uploaded atomic components, the atomic components that are in the repository mentioned by Dimitris, or can upload their own, because for example, some components cannot be in the repository, and then the SMEs needs to upload it. For the developer, so they should insert some information in this GUI, in this form. For example, the name, where the Docker image is, and for example, the minimum execution requirements for the atomic component, and so on. And one important tab is the exposed and required interface tab that is shown in this slide. The exposed interface section is used to specify the interface that the component have with all the required information, like the port, the transmission protocol, and so on. And then we can see that the exposed interface as a way to communicate with the outside of the component. And then the recurrent interface otherwise lists all the external interface that are required from the component point of view to run perfect smoothly. Having inserted this information, the NetApp developer see a list of atomic components in the left side of his GUI. These are all the atomic components uploaded on the GUI, and a NetApp developer can drag and drop to the canvas in order to compose a network application. We can see, for example, with just a click, a NetApp developer can drag and drop and create a link between two components, specifying the interface used. After a network application is composed, there is a save button to save the progress of the composition, and then there is an onboard NetApp network application button in order to build the NetApp package. The click on this component triggers some operation that are the build of a NetApp package, and so from the canvas we have a transformation in information model. This NetApp package is then committed on the 5G GitLab platform in order to trigger a CI/CD pipeline to validate the NetApp package, the network application, and onboard directly on the NetApp toolkit. After that, after the NetApp package is onboarded on the NetApp catalog, we can request a deploy of this network application inside our testbed in very simple click. Let's move on. In this slide, we can see an example of a network application for the automotive vertical service. Since vertical service do not have the knowledge to understand the specific purpose and usage of low-level functionalities, 5G offers a set of open source network application called the Starter Kit, as you can see in this slide here and here. That provide a baseline. This Starter Kit provide a baseline set of application function, network function to be deployed and to support the service operation across different segments. The NetApp Starter Kit, the Network Application Starter Kit, are designed and developed to support the rollout of 5G IANA and third-party use case, taking in consideration also the needs of different type of application. Each starter kit is released in the form of ready-to-use network application in the repository in the NetApp catalog, and where all the information is already specified by us. And so the SMEs and the third party can use this NetApp starter kit as is to create their network application. As I already said, a network application is a composition of application function, network function, and these can create we can compose several network applications in order to create a vertical service. I want to show you an example, a real example of network application and vertical service. This is our use case 5, the real-time road network risk assessment. In this use case, we'll detect aggressive and distracted driving, which are called hazardous event, and we transmit a warning notification on the road risk level to other vehicles. At high level, we can see that this vertical service is composed by several application network functions. For example, the application function 1 implements the position and time service in order to provide accurate information about the vehicle position. The F2 receive and display a warning notification of hazardous event, and the F3 detects hazardous event during driving, for example, the hash braking and so on. The F4 and 5 implement respectively the Elasticsearch stack and the log reporting service in order to store the data to be used in the future. And finally, the 3 network function transmit the data of CITS message, non-CITS message, and especially the network function 3 generated the decentralized notification message that are sent to the NF1 and NF2. In few words, when this vertical service detects an hazardous event of a driver, it sends a notification to a message broker located in the edge. Other drivers which are in the same area of the edge read the message broker and are notified of the hazard event near them. From the central cloud point of view, as I already said, a storing mechanism collects all the metric for the edge and from all the edge and for future use. In this presentation, we have seen the atomic components and the NetApps, and we can see this definition as a building block to create vertical service. And also the atomic components and the NetApps as I already said, are available in our NetApp toolkit to be used from the SMEs. As I said, the building blocks, so the atomic components of NetApp can be easily chained together in a graphical way using the composer that compose a NetApp, a vertical service, and can be this operation is used to compose, onboard in the NetApp, and then deploy the NetApp in our environment. Finally, as I said, we provide a set of NetApps and that are available to use. Thank you.
Thank you, Matteo. And let me try to quickly move on to the last presentation, keeping an eye on the time. I know we have just a few minutes left, or not. But I'll try to be as quick as possible just to take you through the very technical, the very practical issues of the open call. All the information that you might need, they're all in one place, in one page that we have created on the website. You can find the link on the screen, but also if you can, to also type it on the chat box so everyone can access it. It has all the information for third-party experimentation, about the open call, the application procedure, and also the mentors that will be involved in the open call process. Apart from the website where you can find everything, there's also a guide for applicants that we have recently made available. Irene has briefly mentioned the guide earlier. And again, there you can find all the information you might need for the first open call. Like the application procedure, the technical components, everything is in that guide, and you can download it from our website from the page I previously mentioned. Briefly going through the eligibility criteria, you can also find the full list on the guide. For an SME to be eligible, you need to be legally established in one of the member states of Europe or the associated countries and be considered as an SME according to the Commission recommendation of 2003 concerning the micro, medium-sized and small enterprises. Of course, one entity, and it should be independent from the project partners. Now, the most important part is the application form. Of course, after you see all the information about the eligibility, the feasibility criteria, and the whole process of the open call, for applying, you can find the form online. This is also available on the same page that I mentioned before. The application, the applications are open since February 22nd and will be closing in May 22nd at 5 o'clock. The form is very straightforward. It collects general information, any development plans, prior experience, expectations, expected impact. In general, anything that can show us the how and why you would like to use to leverage the platform and its capabilities. It is available there, and yes, you can add the information there. Irene and Dimitris and Matteo have briefly mentioned the technical components of the open call, what happens after the application and how we move to the pre-testing phase and the experimentation phase. Apart from the eligibility criteria, we will be doing a feasibility check on the applications. And again, you can find all this information on the website and the guide. The selected applicants will be informed via email end of May, so 10 days after the application deadline, and then the different phases will begin from June onwards until we move to December 2023, where would be the selection of the award winners based on the criteria that you can see on the left side of my screen. Irene mentioned that the experimenter with the highest ranking of the first open call receive a prize of 15,000 euros, and then we will have 3 experimentals for the second open call. So experimenters that will not be awarded in the first phase, they will be considered for the second phase, and they will be eligible for winning 10,000 euros each. That would be for 3 experimenters. Again, this information is available on the website and on the guide, so you can have the full list of details. And before I wrap up, here are the useful links, the 5G website link, the Get Involved page that I mentioned, and the page that has all the information about the open call. If you have any questions, you can regarding the open call, you can use this email that you can find on the screen. We will also type it on the chat and send it as a follow-up email. But again, you can find it online. And Irene briefly mentioned that, but there are more complementary material coming next that can be useful for understanding the open call procedure and what we were trying to do with 5G and how we can help you. I hope you can stay for 5 more minutes in case you have any questions, but in case you need to leave, I just want you to inform you that the recording will be available and uploaded on the website. So in case you want to return and find any relevant information, it will be there. And I also have all the emails where you can address any general or particular questions that you may have. Irene, I don't know if there are any questions that you can see on the box, because I'm afraid I cannot.
Okay, yes, we have one question by Paolo. What is the total amount of experimenters that will be selected for the first open call? So deliberately, we don't have a number set also in our guide for applicants. The goal is that we will try to accommodate as many as possible, but this will be a function of many factors. So first, it will be how many applications we receive. It will be a function of 5G resources, of course, in terms of mentorship and technical support. Most importantly, of the test bed of Nokia and Telekom Slovenia, because you understand that you cannot access the same resources at the same time. So to answer to your question, we will try to accommodate the maximum number possible, but to find how many we need this information. And we also need your application to understand your needs. So an experiment may need, for example, may declare that they need 1 week. So we will put everything together and try to find the optimum, maximum number possible of experiments.
Great.
I do not see any other questions, Evie, at the moment.
No. All right, and I think we've not just reached, but we exceeded the time for the planned agenda. Thank you for staying with us, even 10 minutes after. Yes, for any further questions or any other requests, please contact us. You can find all the information on the website. And yes, Irene, if you don't have anything else to add.
No, just to emphasize that you don't have to invent the wheel here. So we just need your idea, some basic software, and we can work together to make it a real 5G ready service. So take advantage of us.
Super. Okay, then I think we can wrap it up. Thank you so much to all the presenters. Thank you, and thank you everyone for joining. Follow us on social media as well to get all the latest updates. And of course, as I said again, we're more than happy to help if you have any other questions. So feel free to reach out to us. And yeah, thank you so much all. And have a great rest of your day. And looking forward to receiving your applications.
Thank you very much.
Thank you very much, everybody.
Thank you.
Thank you. Bye-bye.
Bye-bye.
Bye.